Titrations are an analytical method that we can use to work out the concentration of a solution. Now, concentration is simply a measure of the amount of substance dissolved in a given volume of solution, and we measure it with units of either moles per decimetre cubed or grams per decimetre cubed. Now, I've got two solutions here. I've got some sodium hydroxide solution, a strong alkali that I know the concentration of, and I've got some hydrochloric acid solution, a strong acid that I don't know the concentration of. Now, during a titration, what I can do is measure a fixed volume of my sodium hydroxide solution and then add my hydrochloric acid solution until I exactly neutralise my sodium hydroxide. And if I measure the volume of hydrochloric acid needed to neutralise my sodium hydroxide, then along with that volume and the volume and concentration of my sodium hydroxide solution, I can work out the concentration of my hydrochloric acid. Now, my concentration of my sodium hydroxide is 1 mole per decimetre cubed. And I know that my hydrochloric acid is of a similar concentration. In other words, I don't need to be wearing gloves to carry out this titration, but I do need to have my safety specs on. So, the first thing I need to do is measure out my sodium hydroxide solution. And to do that, I'm going to use a glass pipette. And this is a very accurate measure of 25 centimetres cubed. Now, I've already got some sodium hydroxide in my beaker, so I'll use my pipette filler and my pipette. I'm going to draw up my sodium hydroxide. And this is going to go into my conical flask. Okay. Now, what I'm looking for is the base of the meniscus, the curve at the top of this solution, to be sitting exactly on the mark. And then I know I've got a very accurate measure of 25 centimetres cubed. So into my conical flask. I'll just let this drain. Now, before I start the titration, I'm going to have to add an indicator to this solution. And an indicator is just a substance that changes colour when the titration is over. The indicator I'm going to use is phenolphthalein, which is bright pink in alkaline solutions like this one, and will go colourless when the titration is over, when I've neutralised all of my sodium hydroxide solution. We're nearly there. Okay. I'll just pop that over there. So I need to add the same amount each time for each titration. So I'm going to go for 4 drops. Give that a swirl. So there's that bright pink colour. Now, I've already filled my burette with the hydrochloric acid solution. Now, a burette is just another accurate measure of volume. It's a glass tube with a scale down one side and a tap at the bottom. And the tap is closed when it's horizontal and open when it's vertical. Now, the scale reads from 0 down to 50, and I've already set it so that the base of the meniscus of my hydrochloric acid solution is sitting on the 0 mark. So all I need to do now is add my acid to my alkali. Okay. Now, it's really important to swirl your mixture to ensure that the acid and the alkali react and mix thoroughly. And all I'm looking for now is for the colour change, pink to colourless. And as soon as I see it, I need to close the tap. There it is. Okay. Now I need to measure that volume. So looking at the base of the meniscus, I've got 28.6 centimetres cubed. So I've added 28.6 centimetres cubed of hydrochloric acid to neutralise my alkali. Now, in that run, I can't be certain that I didn't go past the end of the titration. So I need to repeat this at least a couple of more times. But when I repeat this, I'm going to be a bit more careful. I know that the the end of the titration is about 28.5, 28.6 centimetres cubed. But I'm going to, in the following titrations, I'm going to stop adding at a lower volume and then add one drop at a time, so I can approach that colour change really carefully and make sure that I'm absolutely certain of where the colour change occurs. So I need to refill my burette and measure out another 25 centimetres cubed of sodium hydroxide, and then I can do a second titration. So I've got my 25 centimetres cubed of sodium hydroxide. I'm going to add some indicator to that, the same amount again, 4 drops. And I'm going to do my second titration. But this time I'm going to add until probably about 25 centimetres cubed, and then approach the volume that I know is the end of the titration a little bit more carefully. Okay, so it's still pink, and now I can add one drop at a time and swirl thoroughly. And just keep a very close eye on the colour of my indicator. Nearly there, and it's gone. Now I'm very confident that that's a much more accurate measure of the volume of hydrochloric acid that I need. And so that is 25.8 centimetres cubed. So in that first titration I did go quite a long way past the end of the titration, but I'm now far more confident of my volume. Now what I need to do is repeat that at least once or twice more and get a similar sort of reading within 0.1 or 0.2 centimetres cubed of that reading, and then I'm confident that I know what volume of hydrochloric acid I need, and then I can use that volume along with the volume and concentration of my sodium hydroxide solution to work out the concentration of my hydrochloric acid solution. And that's how we can carry out a titration to work out the concentration of a solution.